Welcome back. Today we're going to look at the standard form of a quadratic function. So before we get started, remember the standard form is in the form ax squared plus bx plus c. And the question for the first example is, what is the x-coordinate of the vertex given the equation in standard form? So let me write the equation in vertex form. If we remember, it's f of x equals a times x minus h quantity squared plus k. So again, we don't see the hk. The h is that x coordinate. So I'm going to FOIL and simplify this expression. We'll get x squared minus 2xh plus h squared. And then when I distribute the a, we'll have ax squared minus 2axh plus ah squared plus k. So let's look at this equation for just a little bit. So we have a couple things that are very similar, right? We have the x squared here, just like we had the x squared in the beginning, in the standard form, we have the x, right? And then we don't have an x for the last term. So what this means is that our a is going to correspond with our a right here in standard form. Our b is going to correspond with whatever is with the x. So this is really bx. And then this last part right here, that must be our constant. Remember, so you can notice that there's no x in there. So if I set this equation up so that b equals 2ah, I can isolate h. And let me make sure I put a negative because it's negative 2. I can isolate h and divide both sides by negative 2a. So our h equals negative b over 2a. So if we ever want to find the x-coordinate of the vertex, and we're given the equation in standard form, we can find the vertex if we know the value for b and the value for a. All right, so let's practice that. Let's find the x-coordinate. Let's find the vertex for this next example. So remember, I'm going to use the formula h equals negative b over 2a. And I want to identify first the values for a and b. So a in this equation equals 1. B in this equation equals negative 6. And then I'll write down C, we know is 10. Okay, so if we know A is 1 and B is negative 6, then H is going to be negative, I'll put negative 6 over 2 times 1. And that's going to simplify into positive 6 over 2, which is 3. So our H is 3. Now, if I plug 3 back into the equation, I'll get the y value. So 3 squared minus 6 times 3. I'm just substituting that 3 wherever I see the x, plus 10. So that's really going to be 9 minus 18 plus 10, which is 1. So our vertex is going to be 3, 1. The 3 is the h value that we found with negative b over 2a, and the 1 is the y, also known as the k, and we found that by plugging in our x. Okay, let's go to the next example. For this next example, we're given the equation in standard form, and we want to identify the key features so that we can graph it. So I listed the key features that we want to make sure we can identify: the vertex, the axis of symmetry, and the intercepts. So I'm going to use h equals negative b over 2a to help me find that vertex. So let's first identify the values for a, which equals 1, b equals negative 4, and c equals 8. So h is going to be negative 4 over 2 times 1, which is 2. And then when I plug in 2 into this equation, we'll get 2 squared minus 4 times 2 plus 8. So that's 4 minus 8 plus 8, which equals 4. So if h equals 2, and I plug in 2, then my k is going to be 4. So the vertex is 2, 4. Remember, my axis of symmetry is going to be the vertical line through the vertex. So that's going to be x equals 2 or x equals h. And then the last thing I want to figure out is some of these intercepts. So we can tell right away if the vertex is at 2, 4, it's right here, and it's opening up, it's positive, the a equals 1, then it's not going to have any x-intercepts. So I'll write no x-intercepts, right? But to find the y-intercept, I have to plug in 0. So f of 0 is going to be 0, and I could just see it really quickly, but 0 minus 4 times 0 plus 8, so that's going to be 8. So 0, 8 is going to be our y-intercept. So I'll put that over here. And you could tell right away that if this slope is 1, or if the a value is 1, it's going to be up 1 over 1, and then it goes up 2 over 1. So it's going to keep going. So we have 2, 4. When I plug in 1, it's going to be 1, 5, right? And so it's going to be opening up, and I can make that graph here. So I can connect these dots and sketch the parabola. For our next example, we're going to analyze and interpret this graph. So this graph shows us a function of how much a profit a company earns selling headphones at different prices. We want to find the maximum profit the company can expect. Well, you can see on the graph that the vertex is somewhere around here, right? So here's 30 and then 40. So it's somewhere in between 30 and 40. So we have to find that vertex. And remember, to find the vertex, we're going to have to use h equals negative b over 2a. And so when I plug that in, well, we know that a, I'm going to zoom in a little bit, a equals negative 10, our b equals 700, and our c is negative 6,000. So when I plug that in, we get negative 700 over 2 times negative 10. So 700 over 20 would be 35. So we know that the h is equal to 35. And to find the k value, we're going to have to plug in 35 for x. So it's going to be negative 10 times 35 squared plus 700 times 35 minus 6,000. You can kind of see on this graph that it's going to be a little bit more than 6,000. And if we calculate it, it's 6,250. So when we talk about the maximum, well, we know that the maximum point right here would be 35, 6,250. But this is a word problem, so we have to make sure we write this in words. So when we look at it, the selling price of these headphones is going to be $35 per item. And they sell the headphones and I'll put for $35. The profit is 6,250.